Welcome to NASA Edge, an inside and outside look at all things NASA. Joining us today is Bryan Russ from the NASA Langley Research Center. Bryan, thanks for coming on the show.
Hi Blair, thanks for having me on today.
I tell you what, we've had 3 brilliant drop tests and we've had 1 incredible swing test, a success from our standpoint, but tell me, what is different about the swing test from the drop test?
So the difference here, as opposed to the vertical tests where what we do is a fairly straightforward vertical drop, which allows us to impart the majority of the water impact on the heat shield region of the crew module. In this instance, we actually, just what you said, swing. We swing the crew module at a steep pitch angle, and we impact into the pool primarily on the back shells of the crew module. And we are able to impart that force in a much different area and able to simulate a different sort of landing. In this instance, we're simulating more of a launch abort scenario, high winds where you may have a more heavy sea state or coming in at that higher pitch angle into the water.
It seems like you would need to do a lot more preparation from a facility standpoint at the Hydro Impact Basin to perform this swing test. Can you tell us a little bit about that process?
Oh, sure. There's a large amount of preparation that goes into the swing test. I think probably the most obvious of which is the utilization of the integration platform, or what we call the IP. That's a large, about 11,000 pound steel structure that we actually suspend from the gantry 4 pivot winches. And then that's what we actually suspend the crew module from. That allows us to perform that swing. There's an additional bridge crane from the gantry that is then connected to the backside of the IP that then hoists the assembly of the IP and the crew module all the way back. And in this particular instance, they are pulled back to about 135 feet from the front end of the gantry and about 80 feet off the ground. And there's a series of pyros that are used in order to initiate the swing. We have technicians here that install pyro cable cutters. Those will actually fire off and they will cut the cables that'll begin the swing. Right when we get just about to the vertical orientation, there will be a series of explosive bolts. Those explosive bolts will then fire off, then separate the crew module from the IP, and then on it will go and continue into the pool in the final impact.
Because of this elaborate process, and like you said, the explosives and the timing and everything else, is there a point during the test on test day where you reach a point of no return, say where you're going to swing no matter what the conditions are? Or could you call it off, say due to winds or something like that, if you had to at any given moment?
Yes, we actually could. There are protocols for halting the test all the way up into the very end. You know, we have data acquisition systems that are actually gathering all of our test data. You know, there's something that could potentially go wrong with the electrical systems at any given time. And of course, if something happens at the very last minute, we want to make sure that our data acquisition team is able to stop the test, because of course if we swing the test and we don't gather any data, while it may look really neat and exciting, especially for the crowd who's watching, it doesn't really help our loads and dynamics engineers in the end. So we need to make sure that data is triggering when it needs to trigger and is being collected, and that we have a usable product once the test has actually been completed.
How do you and your team, how do you measure success for a swing test?
Well, we really have two important things that we really look at. I think the first would be meeting our impact criteria into the pool, and that really is a factor of our vertical velocity, our horizontal velocity, our impact position into the pool, and then our pitch angle into the pool. All those various factors play into being able to meet the original test conditions that our loads and dynamics engineers are trying to achieve through this particular test. If we can't meet those particular criteria, then of course we're kind of testing a condition that they aren't really looking to test. And in this particular case, we were right on the button for meeting our test conditions, which was fantastic for us. The second thing that we really look at is, as I mentioned previously, we really need to make sure that all of our sensor data is captured. That sensor data is really the number one important product that comes out of the test that we provide to our loads and dynamics engineers. They then take that data and they use that for requirements verifications and correlations to the 3D models. And that allows them to get a greater understanding of our real world test article and how that actually measures up to what they are seeing in the 3D world. And then once you have a good feeling of how those two can correlate to one another, that allows them more knowledge when they go and test many hundreds or even thousands of other test conditions in the 3D space.
Well, thanks so much for being on the show, Bryan. We appreciate it, and we wish you the best as you continue to perform tests for Orion. You're watching NASA Edge, an inside and outside look at all things NASA.